most complex object known in the universe is the human brain. These 86 billion neurons have given us the power to transform our planet. But is this the best nature can do? We now know there are something like 10 billion trillion habitable planets in the universe. 10 billion trillion chances for the brain to be eclipsed by something else. The search for intelligent life is more than just a scientific curiosity. It's driven by a deep desire to connect with something greater. Finding an alien civilization wouldn't just reveal we're not alone. It could chart a new course of evolution for our species. And unlike primitive life, alien intelligence could be detectable thousands of light years away, making them potentially easier to find. What do they know that we don't? And how do we make contact? We're not the first to wonder. "200 years ago, we dreamed of lighting huge rings of fire in the Sahara Desert to signal our presence. And in the 1860s, a French poet proposed a patchwork of giant mirrors, reflecting sunlight to Mars in the form of the Big Dipper. But if you want to send a signal across an ocean of space, bonfires and reflected sunlight won't help you much. Even a nuclear war on a nearby planet would be virtually impossible to detect with current technology. To really get your message across, you need a form of light you can't even see. Radio waves are ideal for carrying information long distance because compared to other forms of light, they travel more freely through interstellar gas and dust. That's why SETI, the search for extraterrestrial intelligence, has focused almost entirely on scanning for radio signals, whether intentional messages or byproducts of technology. Our own radio transmissions have now traveled 100 light years and reached 75 star systems, some of which include potentially habitable planets. And if alien intelligence lies beyond this bubble of signals, they could still infer life on Earth by spotting oxygen in our atmosphere. Thanks to the SETI Institute and the recent Breakthrough Listen project, we have now scanned tens of millions of stars for signals. But despite all this, after 6 decades of searching, nothing. Only a series of false alarms and dead-end leads. We call it the Great Silence. But in reality, the search has barely even begun. There are 2 trillion other galaxies out there that are still too far away for practical study. If space were the size of all Earth's oceans, we would have searched less than a pool's worth of water for signs of intelligent life. On top of this, we might even be looking for the wrong thing. There's more than one way to communicate across space. An alien life might view radio as primitive technology. We have to consider every possible alternative, from the practical to the unimaginable. The search is now underway for a different type of signal, one we could even spot with the naked eye: laser light. High-powered laser bursts can outshine a star by thousands of times and can carry far more data per second than radio. We would have to be in direct line of sight to detect the beam. But spread across many light years, they would widen to encompass entire planets and moons. Fleets of laser beacons could be used to sweep the entire galaxy, like alien lighthouses in a cosmic sea. Thanks to a recent crowdfunding effort, plans are now in motion to monitor the entire night sky for laser pulses. But while these bright flashes would be relatively easy to find, advanced life might be using something far more elusive: neutrinos. Tiny subatomic particles that are streaming through you by the trillions every second. These ghost particles can pass through entire planets and not touch a single atom. It takes a giant room like this to detect just a handful of them per day. But researchers recently proved neutrino communication is possible by sending a simple message through 240 meters of rock. If advanced life is using them to communicate, their signals could travel anywhere, through any obstacle, at the speed of light. Their messages could be streaming through us right now, and we would have no idea. Or maybe intelligent life is taking an entirely different approach to communication, using space-time itself as a medium. By manipulating high-gravity objects, they could in theory create pattern distortions of space-time, which could ripple through the universe in all directions. But making gravity waves strong enough to be detectable would be extremely energy-intensive. Maybe they're up to something far simpler. Placing giant sunshades into orbit around a star could block out starlight in distinct patterns, like a kind of cosmic Morse code. And even though it might take years to blink out a basic message, a system like this would require little effort to sustain. But the most sci-fi possibility of all is that they have left messages in our DNA. Some have proposed that certain sequences of our genes could contain hidden messages, Easter eggs in our genetic code, placed by a life-designing higher intelligence. But far-flung scenarios like this are overshadowed by a more sobering possibility. Maybe we're just in the wrong place, at the wrong time. Using a detailed computer model of our galaxy, researchers have estimated that intelligent life was possibly most concentrated 4 billion years ago, and closer to the center of the galaxy. If true, then we would exist on the outskirts, light years away and billions of years too late to a galactic golden age. Maybe they were here millions of years ago, witness to a whole different planet. By now, they might all be long gone, and we could be living in a galactic graveyard. It may not be their signals that we find one day, but their relics. As it turns out, our chances of finding an alien civilization depend heavily on their average survival time. If the average lifetime is something like 100 years, then they will blip in and out of existence, rarely overlapping, and our chances of finding one alive are slim. But if they survive for thousands of years or more, then our chances will skyrocket as the potential for overlap expands. But what if they're not communicating at all? There's still a way we could find them. We tend to assume that alien intelligence would share our motivation to communicate. But they may find the prospect of making contact too dangerous or too futile. If this is the case, then we have to get more creative in our search. In 2015, astronomers watched as this normal-seeming star began to dim in erratic ways, unlike anything they'd seen before. The cause is probably a giant dust cloud or a shattered moon blocking the light, but it has all the hallmarks of something else: an alien megastructure. And even though this explanation looks unlikely, it hints at a new way of finding intelligent life. Not listening for signals, but looking for their technology directly. Not searching for messengers, but searching for engineers. And to do that, we have to wonder, what mind-boggling alien technology should we be looking for? Each alien civilization would be wildly different, but classifying them by their energy usage will give us insights into what technology they might be using. The Kardashev scale divides them into 3 levels. Type 1 would have a mastery of their home planet, using all the energy available on it. Type 2 would have mastery over their star, harnessing all its solar energy. Type 3 would have mastery over their entire galaxy and would be more foreign to us than we are to amoeba. But before we go searching for alien super technology, how would we find civilizations like our own that have yet to reach Type 1? When a typical planet passes in front of its star, we see the starlight dim sharply. But observing a more gradual fall-off of starlight could be evidence of a dense ring of satellites, a Clark belt. Spotting this type of light curve wouldn't be a smoking gun, but rings around rocky planets are unusual, and it could point us in the right direction. Just as alien vegetation would leave a biosignature in its atmosphere, alien technology would leave a technosignature. Silicon produces a recognizable light curve similar to chlorophyll. Spotting this signal could point us to the presence of alien solar cells. And something more nefarious might also leave its mark on a foreign atmosphere. Alien pollution. Certain pollutants like chlorofluorocarbons aren't produced by nature and could be detectable even in small amounts. These chemicals could even linger long after a civilization dies, pointing us to the remains of an extinct alien race. Such a discovery could give us crucial guidance on how to avoid our own extinction. And there's another universal hazard we would be familiar with. Any civilization that uses huge amounts of energy will produce huge amounts of waste heat. This excess heat could prove a serious threat, just as climate change does to us. But it could also leave a telltale signal. Finding waste heat radiating from alien planets or other regions of space could point the way to intelligent activity. If not exterminated by their own technology, some life forms may achieve total control over their planet and become a Type 1 civilization. With this mastery would come incredible powers. Control over all their world's ecosystems, its resources, and even its weather. But no matter how advanced, every planetary civilization will face the same cosmic threats we do. Gamma ray bursts, supernovas, and asteroid impacts will be a risk factor for any terrestrial race. Some might decide to flee to intergalactic space, reducing their exposure to existential risks, making their home in the voids between the stars. If so, then our search will have to encompass the entire swath of the universe. But alien life that decides to stay planet-bound will need long-term protection. The best way to protect your world will be the ultimate in home defense. A planetary shield. These shields would cause a telltale dimming pattern during transit, and could also emit a detectable heat signature. Large-scale astroengineering like this would require a colossal amount of resources. And the easiest way to get them may not be from mining planets, but from mining asteroids. They are resource-rich and easier to manipulate because of their lower gravity. Searching distant asteroid fields for temperature or chemical anomalies could indicate alien mining activity. Eventually, though, asteroids might not be enough. Since our civilization is so new, any other intelligent life is likely to be more advanced than us. So we should think twice before revealing our presence. But alien super civilizations won't just be looking for resources. They will also need staggering amounts of energy. Stars output billions of times more energy than planets receive. To harness it all requires building something truly mind-boggling. Dyson spheres are enormous megastructures that encircle a star, designed to capture its entire energy output. They could also double as vast habitats for life. A solid shell would be physically unstable, so instead of a sphere, we might find a cloud of objects, a Dyson swarm. No matter their design, they would generate an enormous amount of infrared waste heat. And they could also eclipse or even block out the star's light entirely. Dyson spheres could also be built around black holes, which could have a smaller radius and collect thousands of times more energy. Any beings that come to harness their star's entire energy output will reach the next level on the Kardashev scale. A Type 2 civilization. This level of mastery would imply an astounding capability. Star lifting is the practice of harvesting stellar material and could provide thousands of planets' worth of resources. This process would also allow you to lower the temperature of a star, postponing its death by billions of years. In about 1 billion years' time, our own sun will grow too hot for life on Earth. If we ever find evidence of star lifting, it could inspire us to one day do the same and prolong the game of life. Eventually, there may be life that outgrows its star and needs even more energy. To branch out across the galaxy, life forms this advanced will probably need near-light speed travel. And if they do have this capability, there's a chance we could catch them in the act. Alien starships that hit the brakes at light speed could leave behind a long trail of ionized gas. These trails might emit detectable infrared radiation. Strokes of light painted by masters of the universe. Once life forms have harnessed all the energy their galaxy can provide, they will achieve unimaginable power. A Type 3 civilization. This cosmic virtuosity would be totally unfathomable to us. Life that has built billions of Dyson spheres and can create stars at will. In theory, their thirst for energy could make a whole galaxy go dark. So one way to search for Type 3 life forms is to look for what's not there. In distant space, there are huge voids between clusters of galaxies where no light emanates. These voids were once thought to be evidence of advanced life having harnessed the energy from every star in the region. But it turns out they are naturally occurring features of the universe. And a recent analysis of nearby galaxies revealed no evidence of any galactic-scale civilizations. In theory, cosmic architects could assemble enormous planetary systems far more intricate than anything nature could produce. One possible system that would be gravitationally stable involves 9 sun-like stars orbiting a supermassive black hole, which could support 550 Earth-like planets in a habitable zone. These artisanal solar systems could make ideal long-term habitats, or could even function as an alien nature reserve, with each planet hosting a different strain of life. It's hard to imagine any life forms more advanced than this. But in theory, there could be beings that control or created our universe itself. Researchers are beginning to test the idea that reality itself is just a simulation, or an experiment run by some higher order being. Anything this advanced would transcend our ideas of life itself, as they would exist outside of time and space. In a way, the search for intelligent life is an evolution of the age-old search for God. Both are driven by a longing for truth and connection with something bigger than ourselves. What if we do find a signal one day? What happens when the ancient dream becomes a reality? Just knowing they're out there would profoundly change how we see ourselves. For the first time, we would feel a true sense of cosmic brotherhood. And studying their messages or technology could lead us to huge advancements and help secure our own long-term survival. But the possibility of meaningful two-way communication would be bleak. Separated by hundreds or thousands of light years, we would be studying these civilizations as they were in the deep past. And our experience of language could be entirely foreign to them. But what if, after all our searching, we never find another sign of intelligence? What if we really are alone? We can never be truly sure, as there will always be distant galaxies too far to ever study. But never finding any evidence would mean that our place in the universe is truly unique. It would saddle us with an immense responsibility to keep the flame of intelligence alive. Just as ancient civilizations speak to us through their monuments, we could build monuments of our own for future life to discover. Cosmic time capsules preserving a record of our achievements and our knowledge. Perhaps other races will do the same, and these memory vaults could become connected over time, each new civilization adding a link. It could be our destiny to be the first link in this chain, to be the founders of a galactic encyclopedia built upon by future life forms we will never meet.